right. Feel free to kick it off.
I just had to spam the air horn. Sorry, you may want to take that
That's
away
good.
from me.
All good, all good.
All
Y
right.
can you make your screen, it's like your super high DPI monitors, making it really hard to read?
Yeah, I'm gonna put. Here we go. Is this better?
Yeah, that's good. Cool,
Cool.
thank you.
All right. So I love those. All right. So how's it going, everybody? My name's Sponger, and today I'll be talking about Docker and Kubernetes. So you'll see the theme here is terribly drawn boats because we're dealing with containers. So I did not create these. I stole them from the internet, and I love to have a theme in all my presentations, as some of you may know. So terribly drawn children's boats are the theme. But as far as the agenda, so one of the things that when I first started learning Kubernetes and containers, I worked with the cloud for 4 years in one of my last jobs with my cloud engineering team, and we never touched containers. Some clients and some companies will use containers and some don't. Whether they have a DevOps team, it just depends. Every client I've talked to, in my current role and in my other roles, it really just depends on the client and what their use cases are. And so if you're looking for like how to stand up a Kubernetes environment, this talk is not for you. This is more of just like a high level understanding of Kubernetes and containers, because you can go online and look at walkthroughs and things like that. Like you can go stand up a mini cube, and I have resources for that as well. But this is more just like a high level overview of what the architecture is, because I feel like in order, like before you stand up your environment, it's very helpful to understand like, hey, what's the difference between Kubernetes and Docker? What are containers? What are pods? What are the use cases with Kubernetes or K8s as they're called for short? And so the goal of this talk is to really just understand like the high level architecture, and then also what cloud services you can use to stand up like a Kubernetes environment, and then some lab resources with videos that I've watched and I've recommended some of my teammates watch as well. Um, so let's get started. So containers, what the heck are containers? It's not a shipping container, and I'm just going to read this word for word. A container is essentially like a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably from one computing environment to another. That is a container. And the other piece of this is how containers are spun up. They're spun up through images. And so a Docker container image is essentially, again, a lightweight standalone executable package of the software that includes everything needed to run application code. And that includes runtime, system tools, system libraries, and settings. It's essentially a bare bones version of an application. So, like, if you want to download an Nginx server, then you download the Nginx image and you spin that. You do like a a command called like a Docker pull from Docker Hub, which Docker Hub hosts images. It's public. You can go and look at these images, and then you can pull that image down to your local MacBook, your local Linux machine, whatever you want, and then you can push that into production to basically say like, hey, spin up this application. So if you think about virtualization, I have my desktop here, and I have like VMware on it, and then I'm spinning up, a full-on Linux virtual machine or Windows virtual machines or even a Mac virtual machine. Instead of doing that, containers are just specific services that are running along with like the executable packages. That's all you need. So an Nginx server is just an Nginx server, and that would be like application A. So you have your infrastructure, you have like a host operating system, and then you have Docker to basically run these different types of applications for whatever your use case is. And then there's a happy little person on a boat with the sun. And the other thing is too is if you have any questions on this, like please let me know. I like my talks to be interactive instead of me just talking the whole entire time. Um, but yeah, so let's just get into Docker first, and then we'll go into Kubernetes. So Docker was built as like a containerization platform and runtime, and so Kubernetes is a platform for running and managing containers from many container runtimes. So Docker, if you think of it, is a um, single containerization platform and runtime. Kubernetes is a way to manage multiple of those Docker runtimes, and you can basically set up like, hey, I want to have like three pods or three containers running up at once, and if one goes down, it's automatically going to spin up another pod within like milliseconds, so that container is always up and running. So that's essentially the purpose of Kubernetes, is just think of it as running multiple runtimes of Docker. But so Docker was actually introduced in 2013. Some of the challenges, though, included with Docker was that it included complexity to hold containers distributed across numerous servers. So it was tough to manage multiple runtimes, and that's the whole reason why Kubernetes was essentially born. So you could essentially, with Docker, you schedule multiple containers. You can enable communication between containers and scale them. But when you have multiple container runtimes, that's when it gets more difficult to manage, and that's when you want to shift over to Kubernetes. Um, and so as far as spinning up Docker, you need a Docker file, which is what you create to produce a Docker image when you build it. So that's the other piece of it, is building images. Is that you have a Docker file to say like, hey, I want an Nginx server, I want these specific configuration guidelines. It's a YAML file, and then you can go use that Docker file to build an image, and then you push that. Then you can then use that image to spin up a runtime environment or a actual application. And so Docker is essentially an like Docker is there's different types of orchestration solutions, and those include like Kubernetes, Docker Swarm, Mesos. So Docker again is just being one instance. Docker Swarm Mesos is to have like multiple instances, multiple runtimes. There's HashiCorp Nomad, and there's a bunch of other ones, but the most widely known ones is Kubernetes. And so now we're gonna go into, I guess, does anybody have any questions on that so far before we get into Kubernetes?
One last time.
Yeah.
So the difference between Docker and Kubernetes, right? So like
Mhm.
just I was never really clear on that, um, but I guess Kubernetes is considered an orchestration solution for something like Docker.
Yeah, so Docker's meant to spin up like you can't scale it. Like if you have Google and you have multiple different like pods or containers, like tons of them, and you're trying to schedule them, making sure they're online at certain times. It's an easier way to manage those functions and to build like applications and things like that. Um, like if you think of like an application that's being built, um like the Windows operating system, for example, there's a ton of services in that Windows operating system. Every time you open notepad.exe, that spawns a service. Every time you open, VMware or like whatever your virtualization tool is, that spawns a service. Think of like Windows, this is probably a terrible example, but think of Windows as like the Kubernetes orchestration tool, where it can spin up containers with like notepad.exe or the VMware, or it can spin up like a database for you in a single container, and it's segregated. From containers are supposed to never change, so once you spin them up, they're just up and running. There should never be changes pushed out to those containers. And so Kubernetes is essentially a way to orchestrate all of those different applications that are on your Windows host. I guess, does that kind of make sense?
Yes.
Hey, sp0nger, could I bring something up?
Yeah.
One thing to know about the question in regards to like the difference between Kubernetes and Docker is that Kubernetes, as sp0nger brought up, is an orchestrator, and it's not limited to just Docker, which is actually runs under it's like internal system called containerd. It can also support other container subsystems out there like LXC, and there's like several others that are out there. So
Yeah.
Kubernetes is definitely not limited to just Docker.
Yeah. And that's where I didn't that's a good point. I didn't put that in this presentation, but it's a good point to call it out for next
So
time too.
just real quick. So
Yeah.
if Kubernetes is the orchestrator, then what would Docker be called? Like a container platform or something, or what's the terminology?
It's Is it accurate to say it's a container runtime? It's one container runtime.
Yeah, that's probably the best way to put it.
Yeah. So Docker is one container runtime. As Sean just said, there's multiple different types of container runtime. Like what is it, container D? I think you said, Sean.
Container D is technically Docker, but there's like
Yeah.
LX and a few others.
Yeah, so there's different types of runtimes environments you can set up, and Kubernetes can manage all of those different runtime environment. Here, I'll skip ahead. So this is essentially like like Docker. On the far left hand side, you have like a virtualized deployment where this is like your normal like Windows machine, where when we have like VMs and things like that. So you have your hardware, you have your operating system, you have a hypervisor, and then you have your virtual machine, which consists of like a full-on operating system, libraries, and application. So like a Windows host, Linux host, whatever. But with container deployment and Docker, you have hardware, operating system. Docker is essentially your hypervisor, and then you're running Docker containers with just the app and libraries. So you're getting rid of that host operating system. And then with Kubernetes, you can have multiple Docker containers with multiple applications and multiple libraries in each of them. So these are your different runtime environments. And Kubernetes can orchestrate them. So you can set up networking, you can set up like which containers can talk to each other, which ones are public facing, which ones are more internal, and you can build essentially like applications. Um,
So just real
like
quick, is
yeah,
Kubernetes meant to be like the arrows on the right? Is that where each box that says Docker could be a separate physical server, right? That hosts that Docker, and you've got one Kubernetes thing that talks across the network to all of them.
yeah. So let me get in. So I'll get into that
Okay.
in a minute. Yeah. Let me go over Kubernetes real quick, and then I'll get into that because it's essentially like the questions you're asking. I'm leading up to it, Warlock, and they are like solid questions too. So thank you for those. Um, so yeah, Kubernetes orchestrates the container runtime. This one was created by Google to run billions of containers a week at scale. Like it's pretty insane, like how many containers they run. I know that one of my friends, he used to work for a financial company, and they would spin up thousands of containers like a day. And so that's the thing. Like when you spin up a container, it could be used to just leverage a specific task, even if it's for a second. And so that's like when you're spinning up like large monolithic applications, you in order to create changes in those large monolithic applications, you have to like take, large pieces of that application down, apply the patch or apply whatever you need to, and then deploy them back out. Whereas containers, like the purpose of Kubernetes is to basically take that monolithic application, break it down into smaller subsets, and then you can start creating like a change management process that makes it easier. So instead of taking the whole entire application offline, you're making these small, tiny changes with these containers to this what it used to be a giant monolithic application. You're now doing it in smaller sections, so it's easier, it's quicker. So instead of making a change request, that would take like a month to do, you can do it within like a day or a few seconds. So that's really the purpose of Kubernetes, is to orchestrate container applications and break down those monolithic applications into smaller ones, so you can be more agile and push out changes more quickly. So this was created by Google, released in 2014. It was to better manage container runtime environments. It offers service discovery. You can do load balances within a cluster. You can do automated rollouts and rollbacks. So if you roll out a change and it breaks, you can immediately roll back. Whereas Docker, you couldn't necessarily do that. So like Kubernetes really offers like self-healing of containers that fail, config management, and a lot of the complexities that came with managing or a lot of the there's a lot of extra services and just features that you can leverage with Kubernetes versus Docker. So which is why a lot of companies choose to use Kubernetes or versus like Docker or Docker Swarm, which is Docker Swarm is similar to like Kubernetes. But yeah, so the complexity comes with managing Kubernetes, which is why you can use managed Kubernetes services from cloud vendors as well. So I'll get into that and like what that whole thing means. But essentially, with Kubernetes, you have features like rollouts, rollbacks, self-healing containers if they fail. Whereas Docker, it normally wouldn't have that. So those are some of the features that why companies use Kubernetes. So Kubernetes, you have its large open source ecosystem. It's managed by multiple cloud vendors such as Google, Azure, AWS. It can handle the needs of complex applications, and it can orchestrate across clusters. It doesn't matter if it's on-prem or cloud, you can do either. And Kubernetes has APIs and tools essentially for manage your runtime environments. Whereas Docker, this is Docker Swarm. So now Docker is, one container runtime environment. Docker Swarm can also be used to manage multiple Docker runtime environments. And so that's another competing product with Kubernetes, and it's tightly integrated with Docker system. There's less configuration and choices, and it's easier to learn. So if you're like a small company and you're trying to learn, containers, you could leverage Docker Swarm. But if you start building a complex application that has multiple containers inside of that application, you may want to use Kubernetes. So there's different benefits, upsides and downsides to both. But I think the more widely used runtime management tool is Kubernetes. And so going back to, the virtualized deployment method is your normal method of deployment. Previously, with like your Windows machine could be like the host node, and then you have your VMware as like the hypervisor, and then you have like an actual full-on Linux machine, a Windows machine, or like some type of operating system running. Um, versus container deployment, where it basically bypasses that operating system. Like you have the hardware, the operating system, and then Docker on top of that, and then you basically push out applications and whatever packages that are required for that application. So for like Nginx, you would just be spinning up an Nginx server, and then Kubernetes deployment is used to manage those different runtimes. So as far as the different use cases for Kubernetes, you can deploy a simple app, like kind of like what I've mentioned before. You can microservice a giant, instead of having a giant monolithic application, you can microservice those applications. So it makes it easier for companies to to push out changes to their environment and maybe not have as much downtime and be more agile. And then you can also leverage it to do a lift and shift from on-prem to cloud. Um, there's machine learning workflows that can be used to deploy faster AI-based apps. If you have heavy computing tasks, you can leverage Kubernetes for that. And then I think the biggest thing is CI/CD. So how many of you have heard of CI/CD? It's okay if you haven't.
Yes.
Yes. Okay. Cool. And wow, I
Me.
realize I have some spelling errors in here that I'll fix. So CI/CD is essentially continuous integration and continuous delivery, and the whole purpose of it is to again break down those monolithic applications, put them into smaller containers, and even if like a container is run for like a second, you can make the container do a task or do an action, and then that container will spin down. So it's less compute that you can use depending on the application and the use case. And it's really just to make your application changes more frequently and be very agile, so you don't have to take like an entire application down to push some update out. Um, and so this is the piece where it gets into more depth with like Kubernetes architecture. So as far as the Kubernetes architecture, we have the control plane, which you'll see like a master node or control plane. And what this control plane is you have if an API server to interact with a cluster. So the master node or control plane is on the left. What this whole thing on the you see the Kubernetes cluster, then inside you have the control plane and master node. That's essentially like the API server. And then you have etcd, which is distributed key value stores for config data for clusters, pods, services, nodes. So that essentially holds all of the like the config information for that. And then you have the scheduler, which is responsible to schedule pods to run on your worker nodes. And so what the scheduler does is say, hey, if I want 3 pods or can, and a pod is essentially, you can have in in Kubernetes, there's things called pods, which can consist of one or multiple containers. Usually you want to have one container per pod. And it's weird because in Docker, pods don't exist. Like that concept just doesn't exist. You just have containers. So that's like another thing to note. But a pod is essentially you want to have a 1-to-1 ratio. Normally, if you have more than 1-to-1, it could be like 1 pod to 2 or 3 containers. Maybe there's an extra container in there for backup if one of them goes down for whatever reason. But usually it's a 1-to-1. And so then you have the scheduler that says, hey, I want to have 3 pods up at this time, or I need to have like a replica set, it's called, of 3 pods up at once, and I'm always going to have those 3 pods up. So if one of those like or if one of those pods goes down, or if one of those containers go down, it's going to spin another one back up like immediately. So that's kind of like the self-healing that you have with Kubernetes. And then you have like the controller manager, which maintains the desired state of the systems. So um, essentially, you have your master node, and then you have your worker nodes, which contain the applications in there. And a lot of this on the left hand side, the master node, if you're in a cloud environment like Azure, GCP, um, or AWS, they have like the whole left hand side is part of like Elastic Kubernetes service inside of AWS. So it helps create and run everything on the left, and you just have to worry about picking out which images you want for, like, for example, like an Nginx server to spin up inside of the environment, and you just need to run the commands, and the backend infrastructure is over here is basically maintained by AWS.
Question for you
Yeah.
on that diagram. Okay, so I can kind of see anything with a K in it. That's kind of Kubernetes, right? So, in terms of how Docker fits into this, is it that you'd have one container D on worker node 1 and one container D on worker node 2, where like worker node 1 is like one physical server, worker node 2 is another physical server. Each one's got their own container D.
So I'm trying to think of this.
I'm just trying to figure out how it maps, like where, like
Yeah,
would
so
Docker live within this diagram?
it's essentially, I don't have a diagram for. Let me see. Do I have a diagram for this? Uh, this one.
That's okay if you don't have. I
I
just wanted to
think.
know.
Yeah, it's. I
Sp0nger,
forget.
can I help?
Yeah, go for it.
So if you go back to that last page you were on, that had, there you go. So where, like, you see in the yellow pods, all the little black containers,
Yep.
each one of those is an instance of Docker or containerd or whatever container implementation you're going to be utilizing. You can absolutely have only one implementation of Docker per physical hardware server, but you can have 10,000 on a single hardware server if you want to. And Kubernetes runs, let's use a web server as an example of how you would use Kubernetes. Let's say you have multiple hardware servers and they all are running Docker on them. With identical copies of your web server. And Kubernetes' purpose is to act simultaneously as a service, as a load balancer, and to ensure that whenever any updates are made to the content of the web server, it is simultaneously updated across the system. Does that make sense?
Yeah, so the other thing as far as like updates go, essentially if you have like a pod and or like a container and you need to push out an update, it'll do like a rolling update. So it'll up if you have worker one node 1 and worker node 2, those are like, maybe worker node 1 is like an Nginx server and worker node 2 is like a backup of that Nginx server. You could push out a rolling update which would then just update worker node 1, like those containers and pods, and then it would as soon as like the update goes out to worker node, like the containers and the pod in worker node 1, it'll then start to say, okay, we're good to go, like we're safe, like we can start updating the rest of them, and then it'll update the ones in worker node 2. But
So I guess,
essentially, so
I
so
guess, okay, go ahead.
yeah, sorry, so the last thing. So the other thing is that worker node 1, like you can have multiple, imagine worker node 1 being an EC2 and worker node 2 being an EC2 instance as well. You can have like 50 EC2 instances, and you can have like 1,000 pods stood up on those 2 instances.
So
So
then a
essentially,
pod, so a pod is just a wrapper of a container as managed within Kubernetes.
yes,
Okay. So,
yeah,
okay, yeah, I just wanted to see kind of how they fit together. So essentially, when you deploy a cluster like this, right? I guess it could be that this could be 3 physical systems if you wanted, right? Um, but it actually could just be one master node system and a separate system running worker node 1 and worker node 2. You don't really have to worry about it that much. It's like Docker is just a part of this, and you just deployed Kubernetes, and Docker is being leveraged, and you don't have to worry about it.
Yeah. So and like Sean said too, there's different runtime environments. It's not just like Docker, like with that runs on containerd. There's other types of runtime environments that you can leverage as well with Kubernetes.
All right, thank you.
Yeah. So the other piece of this is nodes. Like nodes are the worker machines that run the application. Like each node runs that container runtime. It can essentially nodes can be added or removed from the cluster dynamically. So you can add or remove. And then pods again, it's the smallest deployable unit and consists of one or more containers. Usually in my use case, or use cases that I've seen with the people that I've worked with, it's a 1-to-1 ratio. But sometimes you can have like one pod with like 3 containers or 4 containers. And the other piece of this is that once pods are deployed and containers are deployed, they are meant to be immutable. They should never change. If you have a change that goes out to those pods, like when they're running, there's an issue. So like in order to fix like the pods are based off of images, and you would want to spin that pod down, patch the package. Like if you have a vulnerable Python package or for whatever reason in your image, and that image is run into a pod and it's live, you would then need to spin that pod down, patch the image, and then respin up the pods based off of that new image that you just had. Um, and so that's kind of how like deployment and like updates run. Is you're not updating the pod because pods are live, they're immutable, they should never change. You update the image, which then affects the which then you can then spin up that image into a pod in runtime. Um, and then inside of the K8's architectures, there's also services. So like IP addresses, DNS, apps that can communicate to each other without knowing the exact IP of the pods. And there's also ingress. It's an optional component that provides a way to expose services to the outside world. So you can have like public and private facing services inside of Kubernetes. So this is another example of like, hey, here's a developer. They leverage the master node to basically push out changes to those worker nodes. And so you have the developer leverages like, you know, Kubernetes commands to push through like the API server to then communicate with your worker nodes, which consists of like, hey, the container runtime is Docker. So like you mentioned, Warlock. Um, there's different types of container runtime. You can have a container D and other ones as well. And then you have pods inside of them, but you also have on the worker nodes like the network proxy, so like QB proxy. So then if you want to make that Nginx server or web server public facing, you basically set that up through like the network proxy or QB proxy. And then so that way your users can then access just the network proxy to serve out whatever content you need. Um, so yeah, I know that's a lot. Any questions on this? Cool. All right,
So
so
where would
now
a system,
go for it.
I'm kind of coming into this kind of halfway, but where would a system administrator come into play with this? Similar to not a developer, but someone who would like learn automation to in this.
Yeah, so I wouldn't in Synac and anybody else, correct me if I'm wrong, I wouldn't really call this a system administrator. I would consider this as part of your DevOps team, where it's part of your development operations, where they're using like infrastructure as code, or they're using like a CI/CD pipeline, which that's a whole other conversation to discuss. Like you can use tools like Circle CI, which is part of like CI/CD, which basically say like, hey, I want to spin up like an image, or like, I want to spin up like a pod like a pod or Kubernetes environment. I'm going to spin this up through like Circle CI, or I'm going to use like GitHub actions to spin up a Kubernetes environment. And so then you're really working on infrastructure as code. And so I wouldn't say it's a systems administrator, because when I think of systems administration, I think of more like you're just managing servers, like Linux servers, Microsoft Windows servers, and things like that. This is more all of your coding, like all of your administration is done through code. So it's infrastructure as code. You're constantly pushing out changes, and it's more of like your DevOps team working with like a change management process and um, like uh, CI/CD tools to essentially manage your Kubernetes clusters and Kubernetes like infrastructure.
Hey, we do it all.
Yeah. Yeah, I don't know. Would you? I guess Sinak, would you feel the same as far as like system admins versus like DevOps?
Yeah, I agree. It's typically when you're setting this up at scale, um, it's as much automation as you can add as possible to do the whole infrastructure as code is going to be probably what you'll see at most companies. But
Yeah.
that's like, don't get hung up on it though, because that's down the road. If you're learning it, don't even like you don't even need to fathom that dot at all.
Oh, you know what?
Yeah,
The other
it's
so the other thing real quick, I was just thinking, sorry, Warlock. So I mean, it also depends on the maturity of your company and how big you are. Because I have worked with clients and different vendors that basically they're like a one-person, two-person shop, and they're just getting into Kubernetes, and they're like, yeah, we're just spinning up this, like, and we have AWS, we use EC2 instances, and on top of those EC2 instances, which are your host nodes, we have Elastic Kubernetes service running. So like I said, we could have like 50 EC2 instances with like 1,000 containers running on top of that EKS service. So it really depends on I mean, you could be a systems administrator, and if you want to learn Kubernetes and implement it, you can. But I feel like when you start to hit the if you're in like a smaller shop, yeah, you might have a systems administrator trying to learn this stuff. But then if you're in a larger shop, they actually have fully built out, teams for development operations, and they have like intricate like CI/CD pipelines and things like that. Then that's really where you're going to get into like the DevOps team, and they're going to have like automation in place, and they're going to be leveraging a lot of Kubernetes services for that.
hey, that's what SREs are for.
Yeah. Yeah. Oh, Warlock, crack me up, man. Um, so yeah, like so inside on top of like Kubernetes, this is like the most difficult thing. Like I've spent 2 years in my last role talking, or in my previous role talking to like engineers, troubleshooting like different implementations, and working with vendors to just or clients to understand what the heck their infrastructure environment is set up. Because the thing is with Kubernetes is there's multiple different ways to do it. You can have EC2 instances hosting your EKS. And usually, clients leveraging this is you can change how large your EC2 instances are. So, say you have like a bunch of containers that require a ton of compute services for whatever reason, you may want to leverage EC2 instances, large EC2 instances, because then you could have like, 1,000 EC2 instances that are huge, like they're packed with CPU, they're packed with RAM, and you're just running like, thousands and thousands of containers on them. Or if you don't want to run Kubernetes, you can leverage Amazon's Elastic Container Service, which is completely different, and pods do not even exist in Elastic Container Service. So there's that option. And then you have Fargate. And Fargate essentially gets rid of the EC2 instance, and Amazon manages that for you. So now you're not even spinning up EC2 instances, because if you spin up an EC2 instance, you still have to patch it, you still have to manage it and maintain it. But with Fargate, Amazon does that for you, and now you're just leveraging the Fargate service to spin up those EC2s for you automatically, and you just have Elastic Kubernetes Service on top of that, which now you're just truly spinning up containers and pods and different applications, and that's it. So you don't have to manage that. But it can get really expensive, because again, if your applications that you're running takes a lot of compute power, you're going to pay for that on Fargate versus EC2 instances where you can manage yourself. So it really depends on how, like, what the use cases of the client is doing, and how your company wants to build this out. The other thing is a lot of different antiviruses. They may not have container sensors, so they just have sensors like antivirus sensors that deploy to the EC2 instance versus having a container sensor. And so then if you have 100 EC2 instances and a couple thousand containers, you're gonna technically a company could deploy to just those 100 EC2 instances, so that's all you're paying for. But then if you're looking looking for that runtime protection and you don't have EC2 instances and you're leveraging Fargate with Elastic Kubernetes Service, well, then you're going to have to pay for those thousands of containers. So that's 1,000 licenses or 2,000 licenses. And so it depends on there's a lot of planning, and I think that needs to be considered with your application and your use case before you even start this whole process of building this out. And then you have Fargate and Elastic Container Service, and I'm not going to get into that. And there's so many different acronyms. Oh my God,
There's
WTF,
there's
BBQX.
Hey,
there's one more option.
Yeah, which one is that, Warlock?
So, well, I think you mentioned it verbally, but it's not on this list, which is purely just you spin up your own EC2 instances and you do your own installation of Kubernetes yourself.
Yes,
That
and
is an
that
option.
God, that is
Good
an
luck.
option. It doesn't scale well, and it's going to be a pain to manage because you're going to have to manage. You're going to have to essentially manage the whole
Yep.
entire API server, all of the controllers, the schedule, the key value store. Like you're managing all of this, which
Yep.
Elastic Kubernetes Service manages all of this for you, and you're just worried about spinning
It's
up
just
the
it's a sliding
pods.
scale of control, right? So
Yeah,
if you
yeah,
want that control and you literally don't want to be using even EKS, you can totally just get your EC2 instances, get them whatever class of size you wanted, and deploy it all from scratch as if you were doing it on-prem. But good luck.
yeah. And you can do it on prem too. If you want to do all this on prem, you don't want to deal with the cloud, like you can do that as well. But the reason why people come to the cloud is because it's just easy to it's easier to manage and maintain this stuff.
Yeah, and I apologize. I did interrupt you, Sinak. What were you about? What were you going to say?
No, I was just gonna let you know we're almost at time.
Okay, I'm almost done. Azure has Kubernetes. Google has Kubernetes. I won't get into that. Actually, I'll get into that real quick. Google has Kubernetes engine, which essentially you can run it on Ubuntu or container optimized system, optimized operating system, and that's just really a lean version of just uh, like a it's a lean version of a container runtime operating system. So yeah, there's that. And then as far as lab resources goes, like I said, like this is more of a high level talk to just get you into understanding this. So if you wanted to go deploy your own Kubernetes environment, you can leverage Minikube and you can run that on your own Mac or your own Linux machine. And it's just as simple as just following the docs for getting started. Also, if you want to do a full course, I actually watched this Tech World with Nana. She's amazing. I love her Kubernetes and Docker videos. She has like a full course in 4 hours that you can go watch, and I put it on like 1.5x, 2x speed, and then just like blew through it, and I learned a ton from it. Um, and now I put, since we're dealing with shipping containers, I figured it would be amazing to have a Captain Jack Sparrow on a ship that's sinking because containers can be very, very, very confusing sometimes. But hopefully this helped clarify some of your questions.
All
But yeah,
hail the pirate chain.
all hail the pirate chain. um,
So, just real quick,
yep.
I mean, I run Proxmox, so I was just kind of thinking as you were going through this, like if I wanted to deploy this real quick, if there's anybody here that's familiar with Proxmox, like I know Sinak is, I'm just thinking like, just for me, it might be easy to deploy the master node, I guess, or an instance of Kubernetes, maybe just with a Proxmox container, because they have a bunch that are available. I haven't looked into it, but if there is one, that might be a really nice way for me to just grab that container, or a Proxmox container is what I mean, and it's just a virtual machine, and just grab that, spin it up, and there's my K8s master node with all the crap all deployed nicely, which might be a short way to short circuit, so I don't have to do the Minikube thing. So I'm gonna look into that. I'll report back.
Yeah, let me know. Um, and the last thing is too is like some of the things I mentioned like Docker Hub. You can That's the whole thing. Like you can spin up BusyBox, Ubuntu, Python, Postgres, like MariaDBs, MySQL servers, and you can spin all of these up in your containers. I mean, Jesse's gone over spinning up containers and things like that. There's just tons of different images that you can leverage. Also, be very careful, and if there are open source image scanning tools that are out there, I highly recommend if you're downloading images from the internet, use those open source tools to scan them and look for vulnerabilities because this is a public facing system or public facing website, and people can purposely upload malicious images or compromise images, which then you then download and spin up your environment. So
So
that's
I
another
mean,
thing you want to
isn't that the whole
avoid.
thing where like, if you download an image from Docker Hub or something, you're not actually like, I mean, I guess you can download an actual image binary file. I'm not sure how that works, but I mean, isn't it where it's all built from like this manifest? It's like a text file kind of thing. So like if you just got that
Yeah,
and then built your own from it, at least you know exactly what it was built from. You can read through that. It's just text, right?
yeah. Essentially, yeah, it's literally a YAML
Yeah,
file.
that'd be the method I'd prefer.
Yeah, there's Docker official images, there's verified publishers, but I mean, the whole point of being an attacker is if you can compromise one of these and somebody downloads it, then winner chicken dinner.
Hooray, supply chain attacks.
Exactly. The other thing is, before we're done, just a few things left. kubectl cheat sheets. Kubernetes has a bunch of them, which you can look at the different cheat sheets for the commands, so like list pods, looking configs, apply changes, creating objects, and things like that. So this is a great cheat sheet to have. I'll post it in the I have it in the PowerPoint presentation. Kubernetes, like this is like or OpenAI and ChatGPT, like this is very helpful in learning Kubernetes. So if you have questions on it, and you're not quite sure, maybe you've read through the Kubernetes docs, but you still don't quite get it, try, ChatGPT, because I actually leverage this for to learn about init containers and like injection of like specific images into containers and things like that. And then the last thing is, I won't talk about a Docker registry, how to set that up. That's a whole other thing. But yeah, Minikube can be very helpful. And then also in the presentation, I put like what you'll need as far as like a Minikube setup. It's super simple. 2 CPUs or more, 2 gigs of free memory, 20 gigs of free space, an internet connection, and you can just run through this and set up your own Minikube for containers. And then this is the complete course, Tech Talk with Nana, or Tech World with Nana. She's amazing, and there's a bunch of other Kubernetes and just like microservices that she goes over and why it's needed.
So here, real quick, if I were to find a VM, let's say, right, or whatever, and just download it and run it in Proxmox or something, right, to get
Okay.
the master node kind of deal going, is there a happy fun time front end, like a web front end or something like that? Like once I've actually spun it up, is that part of the Kubernetes thing, or literally is everything command line? Kubectl this and kubectl that.
So once you, so once you spin that up, like if you spin up an Nginx server, you're literally just going to go to your local IP address and it's going to be up.
No, I mean
Is that what
for
you're asking for?
Kubernetes itself, right?
Oh, it's all command line. It's all
Oh,
OP in terminal.
there's no snappy web front end or something that it's like baked
There,
into it that you can use, or
Synact, I don't think there is one.
Yeah, I've never seen one.
Yeah,
I'm
I've
sure
never
there
seen
is,
it.
but I've never heard of one.
Yeah, everybody's gonna be using like these commands essentially here, like creating objects, like here's your
I'll,
manifest YAML and all that
I'll say
stuff.
technically, if you use like a cloud service like AWS, you'll technically get a GUI. So there's that.
all command line all the time.
Yeah, and I mean Circle CI is one type of like CI/CD. So this is where you can build out like you'll have different actions to say like, hey, create this runtime environment, like build an image, deploy the image, and you'll have like basically a set of tasks that you can do um, to to manage and maintain your Kubernetes environment.
All right, guys. Well, I'm gonna wrap this up. We're at time, and I have to actually bounce.
Thanks all.
Great
Good
talk,
talk.
man.
Thank you, Sponger.